Number 2 is hard to see. There's a horizontal line right here that is really easy to not notice. So you might fix that on yours. There's a horizontal line right there. Okay, so number three is tricky. It does have a rational graph, and it has a cubic. So number 3 is going to be a little bit tricky because there is an x-intercept we're going to have to find. The domain is going to be a little bit weird. The range is going to be a little bit weird. Number 3 is a good one to try. Yeah. Number 6 is another kind of funky looking one. Number 6 is going to kind of have a weird domain to it. It's going to have a weird range. We're going to have to find the x-intercept there. X-intercept is going to be a decimal. End behavior is going to be interesting on this one. So number 6 would be a good one. Let's see, number 4 would be a good one. The domain is going to be kind of funky on that one. The range is going to be a little iffy on that one. The x-intercepts you can just see by looking at it, so that those aren't very interesting. Domain's kind of weird on this one because there's a gap in there. So of those ones I kind of pointed out, which one would you guys like to do? 3? Once we do the other ones, you'll find the gap isn't the worst thing. It's really not. It's so the gap versus the ones that have the rational functions. The rational functions are going to be the ones that are a little bit trickier, the ones that have the fractions in them. So number 6 has a rational function. So we've got, I'd look at 3, 4, 6. Which one do you guys want to do? We've got to vote for 3. Everyone cool with doing 3, 4, 6, 3? Let's do 3. Okay. All right. So we'll just start at the beginning. First thing we want to do is figure out what piece to plug -8 into. First one, okay. So I'm gonna do. I gotta get a fraction on my screen. How do I do that? Alpha y equals, okay. So I've got 1 over -8 plus 4 with a -3 on the end. Okay, -13/4. Okay. Which one do I plug a -2 into? The first one? Okay, so I'm going to copy paste this, and I'll just take the -8, turn it into a -2. -5/2. Okay. Which one can I plug a 1 into? The bottom one says equal to 1. So I'm going to have 3/2, or I can do a fraction. I'll do 3/2 times the cube root. How do I get to a cube root? I'm going to hit the math button, go down to number 4, and then I'll type in 1 minus 2, -3/2. Okay. And then which one do I plug 3 into? Same one? Okay. So copy pasted it, plug in 3, positive 3/2. Okay. Domain. So the domain is what? What do I have to think about when I look at the graph to find the domain? What does domain mean? The x's. I have to look at the x's. So I have to look at the picture from the left to the right. So on the far left, I see an arrow. On the far right, I see an arrow. So now I have to think about, are there x values that are getting skipped? So I'm starting off in my head, I'm thinking, okay, the domain is probably from negative infinity to positive infinity, but are there x values that are not being used? So here I'm a little bit concerned about the x value of 1, but should I be concerned? No. So it looks like it's not being used here, but then up here the x value of 1 is being used, so I don't have to leave it alone after all. X value of 1 is being used. But if I look over here, I'm going to use a marker so you guys can see it really well. I have a vertical asymptote that's showing up from the rational function, and that vertical asymptote is at x equals -4. Is that vertical asymptote a value for x that is being skipped? Yes. That's an imaginary line. It's an asymptote. It is not being crossed. That value is being skipped. So I have all of my x values except for -4. -4 is being skipped. So how do we write that? Does anyone know how to write that? Will you pass that to Kim for me? How do we show that we have all of the x values, but we're skipping -4? We're going to use parentheses. Yeah. So we're going to do negative infinity up to -4. So I'm going to write negative infinity up to -4, and I'm going to put parentheses because I'm not using -4. So this set of parentheses represents this side of the graph. Negative infinity up to -4, all of this part of the graph. And then I want to show this part of the graph over here, which is going to start at -4 and then go all the way to infinity. It's going to start at -4 and go all the way to infinity. And it's not going to include -4 because that's a value that's being skipped, and so I'm using parentheses. So this is how you write the domain if you're skipping one value. Does that make sense? How you would skip one value? So when you're doing these problems, I think you might skip 2 values, but for the most part, you'll probably just skip 1 value. Now, if you have 2 answers in interval notation, it's proper to put the u in between. If you don't put the u in between, I will not mark you down. Sometimes you'll end up in college with a professor who doesn't like it when you don't do that. For the most part, people don't care. But it's technically inaccurate if you don't put the u. It is accurate to put the u. I don't really care. Okay. For the range, we're going to go from down to up. So if we look from the bottom to the top, because we're talking about the y values here, at the bottom I see an arrow. At the top I see an arrow, so I'm starting off with negative infinity to positive infinity. That's what I'm starting with. And then I'm going to look to see if any y values are being skipped. So are there any y values that we might be worried about? Anybody see any y values we might be worried about? -3. So I'm looking like -3 is a y value that I'm concerned about. And definitely I'm concerned about it right here because of this little hole right there. In fact, I don't even know if that's actually at -3. I'm going to have to check that. But I'm definitely concerned about the -3 because of the horizontal asymptote. So y equals -3. So this bottom portion of the graph is pretty easy to write a range for. What do you guys think we should write for this bottom portion right here? Negative infinity up to negative 3. Okay, negative infinity up to negative 3. Okay, so that's this portion of the graph. Now, if this wasn't a piecewise function, if this part did not get cut off here, then I would just say the rest of the graph was negative 3 to infinity. But this gets cut off here. Everyone see that? It gets cut off, and that's probably a decimal, and that decimal is not negative 3. Does that make sense? That decimal is not laying on the negative 3 line. It's above the negative 3 line. Negative 3 I got from the equation right up there. So these problems would be impossible to do with accuracy if I did not give you the equation, which is why I gave you a picture to work with, but I also gave you the equation to work with. Does that make sense? Because sometimes we might have to go back to the equation to be able to answer them more accurately. Does that make sense? So yesterday we were mostly using the picture to answer the questions. That was why that was part 1 of the assignment, just to get you guys able to do some of these questions visually. And now today we're going back in and we're saying, okay, I'm still doing it, but sometimes I might have to use the equation to help me do it with a little bit more accuracy. So if this line was getting right up close to the asymptote, like the other one, then I would say negative infinity to negative 3, negative 3 to infinity. But it's not, it stops suddenly, which means that line doesn't get super close to negative 3. It actually stops at a decimal. Does that make sense, that it stops? So how are we going to figure out what that y coordinate is right there? How could we find it? We have the equation. We have the x coordinate. How could we find the y coordinate? Any ideas? We could plug it in. So we know that it's from the rational function. We know it's from an x coordinate of 1. So we can take that x coordinate of 1 and we can plug it into the function. And then we know it's going to get a parenthesis, not a bracket. We're not actually going to equal that point, but we know that that's going to be the lowest point for that portion. It's never going to actually get there, but we know it's going to be the lowest point. So let's grab our calculators. I'm going to use the first portion of the graph. I'm going to plug in 1 over, and the x-coordinate is a 1. 1 plus 4 minus 3. Negative 14/5, or if you don't like the fraction, you can turn it into a decimal. I hit the math button, and I'm going to turn it into a decimal. Negative 2.8. So it doesn't get close to 3, it gets to negative 2.8, and then it stops suddenly. And that is a hole on the graph. It's a point where we don't go any further. And so I'm going to say negative 2.8 is the lowest portion of that part of the graph. And then from there, this goes up forever. So for this part, I'm going to say negative 2.8 to infinity. So the range on this one was a little tricky.
Even though it doesn't hit negative 3 ever, you still put it on as a similar equation.
So this part we use negative 3 and we put a parenthesis, and that parenthesis because it does not hit negative 3. And then here we can't put negative 3 because it stops right there and has a hole. Now if this wasn't a piecewise function, it wouldn't stop there and it wouldn't have a hole. It would actually continue on and it would go like this. It would have a little arrow and it would show that it was getting closer to the asymptote. If it wasn't a piecewise function, this would have a negative 3 right here. But because it is a piecewise function and it stops suddenly, that's why we had to find that decimal and see where the number was at. Yeah. We did not need to use this piece right here to help us figure out the range, because this piece right here made it so that one right there was redundant. It would tell you the same information twice. Does that make sense? So this part was the hardest, the most difficult part of this problem, was this part of the range right here. That was the most difficult part of this problem. Okay. If we put our stick figures here, my stick figure's right here. He's going to start walking. Is he walking uphill or downhill? Downhill, so he is decreasing. And what value, we're using x values, right? Increasing, constant, and decreasing, those are all x values. So he starts at a left arrow. And what number do we use for a left arrow? Negative infinity. And he is decreasing, and what is the x value right here of this asymptote? Negative 4. Okay, so he is decreasing from here to here, and so what am I going to write for my interval? Negative infinity to negative 4. Okay, so for the first interval, we're going to say negative infinity to negative 4. Does anyone know why I would put a parenthesis around the negative 4? It's not going to touch it. It's an asymptote. It's not a value that's actually on the graph. Are we good so far? Okay. Now that stick figure fell down the asymptote and he died, and then a new stick figure dropped down from the clouds. All right. This stick figure starts at this x value, and what is this x value? Wait, the x value? Negative 4. Right, you see that it's an arrow, but that's the y value. The arrow pointing up is a y value. The x value right here is a negative 4. Okay, and what is this stick figure doing? Decreasing. He's going downhill. And he goes downhill all the way to this x value right here. And what x value is this? It's an x value of 1. Okay, so decreasing, and what should I write for this interval? Negative 4 to 1. So he starts at negative 4, goes all the way to 1. So we're going to say negative 4 to 1. And somebody tell me, why did I do parentheses for both of those? The 1 doesn't count. It's a whole. And then why did I do it for the negative 4? It's still an asymptote. It's still a value we can't have. Okay? What should I put in between my two answers? I should put a U in between my two answers. Okay, that stick figure fell into the hole. He got stuck. It was like Indiana Jones when you walk through the quicksand and it grabs onto your boot, and then it gets in your boot, and then it grabs onto your leg, and then it grabs onto like your knee, and then your whole body, and then you drown. It got real serious real fast. Does everyone feel a little sad? Let's move on. There's a new stick figure. He's right here. Okay, what number do we have here? What's the x value for the new stick figure? 1. Okay, and this stick figure started walking. In which direction is he walking? He's increasing. He's walking uphill. Okay, and he starts at 1. He increases, and he gets to this x value, which is a right arrow. And what number is that? Infinity. Okay, and for this one, I'm going to put a 1 with a bracket around it and an infinity. And why did this one actually get a bracket when nothing else did? Because it's a point, it's here, it's filled in. So it's kind of like you're getting on the escalator at an airport, but this escalator at the airport would be a really fun one. I don't know, I'd be down if it looked like that. 1 to infinity. Okay, a constant interval would be if it was completely flat, not going up, not going down, completely flat. So here we're going to say none. There were no constant intervals.
That's like this, and it's straight up. It's still increasing.
Yeah, it's like you're climbing straight up a mountain for a second. Yeah.
But if it was turned the other way, then it would be.
Yeah, but so if it was flat, it could be constant for just an instant, but we don't mess with that in this is still like a lower level math class. We wouldn't mess with that. In calculus, they address it, but we don't address it. Yeah. All right. Maximum. Are there any mountaintops? No. So we're going to say none. There's no place where it goes up and comes right back down. Minimum. Are there any valleys? No. It doesn't go down and come right back up. Okay. X-intercepts. I see 2. There's one that I can see easily, so I'll go ahead and write that one down, the 0.20. And then for the other x-intercept, I'm going to have to use my calculator to find it. And for the y-intercept, I'm going to have to use my calculator to find it. So x-intercept right here, y-intercept right there. Which piece are we plugging into the calculator so that we can find the intercepts? First piece or the second piece? The first one. The first one is the rational function, and that's the one where we have the intercepts. So I'm going to go ahead and graph this now. So I've got 1 over x plus 4 minus 3. And I can see there's the x-intercept right there. Here's the y-intercept over here. And do we remember how to find an x-intercept? What do we do? Second trace. Yep, 0 is the x. 0 is another word for x-intercept. So second trace number 2. And we do the left bound and right bound. And the x-intercept is between what 2 numbers? Yeah, looks between -4 and -3. Okay, so the x-intercept is -3.667. And then what do we do to find the y-intercept? Second trace number 1, plug in 0, -11/4.
For some reason, I thought that for the one that's a y and the one that's an x, for the y one you could say equals that and plug it in. Can you do that? Like if the fx equals y, technically.
Uh-huh.
And then you do the opposite. You plug in the x.
To find the x-intercept, you could plug in y equals 0. Is that what you're saying? You can, but it's not the same process. You would go over here and you would plug in y equals 0 right there. And then you would do second trace and find the intersection. So it's going to be a different process no matter what than finding the y-intercept. Yeah. Some teachers teach it that way, and I just teach it this way because this means x-intercept. So it just kind of depends on your preference. Yeah. Okay. Is the graph continuous? Can you trace it with your finger without picking up your finger? No, this is definitely not continuous. You trace it, pick up your finger, trace, pick up your finger, trace. So this is definitely a no. This graph is not continuous. Okay. End behavior is just talking about the arrows that are on the very left end of the graph. So this arrow. And the right end of the graph, that arrow. So there's a lot of arrows on this graph, but these are the only 2 that we're talking about for end behavior. The far left arrow and the far right arrow. So as we look at the left arrow, is the arrow going up or down or leveling off at a specific number? It's leveling off at a specific number, and can you tell what the number is?
Oh, no, you can't.
You're right.
Oh, -3.
Yeah, it was -3. So the number is leveling off where that horizontal asymptote. It's going to stay at -3. So we're going to say as we look at the left arrow, we can see that it stays at that horizontal asymptote, which is -3. Our left arrow goes to -3. As we look at the right arrow, what do we see for the right arrow? Yeah, it goes up forever. It doesn't go super fast, but it does go up forever. So y goes to positive infinity. Okay. So some of the parts are going to be really easy to answer, and some of the parts are going to be kind of like the range where it's going to hurt your brain a little bit to think about it. But exactly like what we did yesterday. So the parts that are going to be probably a little bit tricky, domain and range, you're going to definitely want to be careful as you think about them. The x-intercept on today's assignment, you're going to be more likely to have to plug something into the calculator to find them. More of these have decimals for the x-intercepts. And then you're going to want to be careful with your increasing and decreasing this time. Okay? All right, go ahead and get to work, and I'll start getting one done to put an answer key on the board. Yes?